So today we're going to be going through this example of arithmetic progression amortization. So what do we mean by that? That's when we have payments in the plan that increase or decrease by a constant value each period. And to calculate the payment, we're going to be using the formula of the present value of arithmetic gradients in general. So here it says to prepare an amortization plan, or amortization table is another word for it, of a $15,000 loan to a 5-year term with annual payments at an interest rate of 10% per annum, with a capital payment and interest that will increase by $500 each year. Okay, so the first thing we need to do is we need to calculate the first payment. Now, to calculate the first payment, we need to use the present value equation for arithmetic progression in general. So just a reminder what that formula would look like. That formula states that the present value is equal to A, the payment, times 1 minus 1 plus I to the power of negative n all over I plus g over I, where g is the gradient amount, times 1 minus 1 plus I to the power negative n over I minus n times 1 plus I to the power negative n. So I get that that's a lot. First, before I even try to plug in the numbers, I just want to state what the numbers are that we know. Well, we know that the present value is $15,000 because that's the amount of loan we are initially taking out. So I'm going to write that over here, that present value equals $15,000. Then we have A, which is the thing that we don't know. We're trying to figure out what that first payment would be. Then we have I, the interest rate, which is 10% per year. We can keep it at 0.1 or 10% because in this case the amortization is yearly as well. It says it'll increase by $500 each year, so that's a set amount extra every year. And speaking of which, the gradient amount, G, is $500 because this goes up $500 every year. And then last but not least, we have N, which is the number of years. I think it said 5-year term. Yeah, 5-year term. Excellent. So N is equal to 5. So then we're just going to plug in all those numbers here, and we're going to figure out what A is equal to. So therefore, $15,000 is equal to A times 1 minus 1 plus I, so 1.1 to the power of negative 5 all over 0.1 plus 500 over 0.1 times 1 minus 1.1 to the power negative 5 over 0.1. And then that's minus n times 1.1 to the power of negative 5. Oh, and here actually I should put 5 because in this step we're subbing in everything and I'd forgotten to sub that in. Okay. Now, a lot of people will say that at this step is where they'll commonly make a mistake just because there is a lot of, there are a lot of things to calculate here. So I'm going to help, give some ways to hopefully not make any of those mistakes. Let's start by figuring out what this value is specifically. So what I'm going to do is I'm going to type into my calculator 1.1 to the power of negative 5. I'm going to hit equals. And then I'm going to do 1 minus that answer that we just got. And then I'm going to divide by 0.1, hit equals again. And I'm getting 3.79 approximately if I round to 2 decimal points. So therefore, so far we have that 15,000 is equal to 3.79 times A. Then we have plus all this stuff. So notice that we have all of this in these square brackets here, and then we have times 500 divided by 0.1. So what we're going to do is start with what's inside the brackets. So let's start with 1.1 to the power of negative 5 equals, and then 1 minus that number, and then divide by 0.1. And if we've done this correctly, we actually, because these two things here are the exact same. And so we should get 3.79 approximately there. We should get the exact same answer that we got for here. Then we're going to subtract 5 times 1.1 to the power negative 5. So I'm going to type in 1.1 to the power negative 5 equals, and then times negative 5 equals, right? And then we can add, if we didn't already, 3.79. And then that's going to be about 0.685. We're going to multiply by 500, hit equals, divide by 0.1, hit equals. And here I'm getting 3,426.97 when I round to 2 decimal points. Okay, so at this point, this looks a lot simpler to work with. This is just a standard linear equation. We first need to subtract $3,426.97 from both sides. So let's do that. And then we need to divide both sides by 3.79, so we could just do that all in one step. I think at this point in our math career, that's probably fine. So therefore, A is equal to $3,053.57. So there we go. That's some key information to do our amortization plan with. We really needed to know that first payment, and well, now we know. Now we know. All right, so now let's talk about how to do the amortization plan when it comes to arithmetic progression. So now that we figured out this A value, we can figure all this out. First, I'm going to write the number of years, then the loan balance, then the capital, then the interest, then the capital plus interest, okay, and now for years, it's a 5-year term. So I'm going to write 1, 2, 3, 4, and 5. Also, we know that the first the first payment is going to be the payment with the capital and with the interest. So that number we found earlier, that $3,053.57. That is going to be our first capital plus interest. So we'll put that there. Later, we'll discuss how we can figure out how much of that is capital and how much of that is interest. And keep in mind that if we know a way to find either one, we can easily find the other as well, since we know that both those together, the full payment, is $3,053.57. Also, the loan value in the or the loan balance rather in the first year is $15,000 because that's given to us in the question. So that's stuff we know immediately just from looking at the question, or in the case of this $3,053.57, it's what we just calculated. Okay, so next what we need to do is recognize that it said that the gradient is $500. So that means that the overall payment is raised by $500 every year. So the capital plus interest, which is our full payment, needs to be raised by $500 each year. So in other words, that means in the second year, we're going to pay $3,553.57. Then in year 3, we're going to pay $4,053.57. So yet again, another 500. Then for year 4, another 500. So $4,553.57. And then in the last year, yet another $500. So that's going to in total be $5,000, $5,053.57. And there we go. Okay, so next step is we need to figure out how much is capital, how much is interest, because once we figure out those things, we can subtract the capital from the loan balance each year and kind of do a repetitive process that way all the way down in order to figure all of this out. So earlier in the question, it said that the interest rate is 10% per year. So what I'm going to do is I'm going to take the loan balance, which is $15,000, and multiply by 0.1, which is the equivalent decimal to 10%. And if we do that, we get $1,500. So that means of this total payment, $1,500 of our very first payment is going to interest, and the remainder must go to capital, right? Because we only owe $1,500 of interest that first year. So therefore, if we do $3,053.57 minus the $1,500 that goes to interest, we'll get that therefore $1,553.57 was able to go to capital. So since that went to capital, that means we now owe that much less for the second year because we paid off $1,553.57 of our debt. So now we're going to subtract that from $15,000. So now at the beginning of the second year, we now only owe $13,446.43. Okay, so now we need to know, okay, how much interest do we owe on that? Well, now another year has passed, it's now year two, so we owe another 10% interest. So multiply by 0.1 gives me that the second year, we now have to pay $1,344.64 in interest. And the total payment now this time that we're making in year two is $3,553.57. Only the first $1,344.64 is going to the interest, so the rest can go to principal. So I'm just going to subtract $3,553.57. We're going to do that minus $1,344.64. So that tells us that $2,208.93 can go to capital. That means we now owe that much less on the balance. So we're going to subtract that from the overall loan balance at this point, which is we're going to subtract it from $13,446.43. So if I do that, I get that we only owe for the third year $11,237.50. Okay, so now how much interest do we owe? Now another year's passed, we owe this much. How much interest do we owe? Well, we owe 10% interest, so times 0.1. That means in interest, oopsie, we owe $1,123.75. Now we're going to subtract that from the payment we made. We made a total payment of $4,053.57. So let's subtract that. Okay, so therefore the capital we paid off in this one was $2,929.82. And we're going to subtract that from our overall loan balance to figure out how much loan we still owe in year four. So let's do that. Okay, so therefore we now only owe $8,307.68. Okay, and how much interest do we pay that year? Well, we're going to multiply by 10% or 0.1 and see that we owe $830.77 of interest. But the rest of our payment, which is over $4,000, can go to principal, right? Our payment's $4,553.57 this time. So let's subtract 830.77 from that number. And we end up getting that the rest of it, right, the rest of the payment that went to capital was $3,722.80. And now we owe that much less on the $8,307.68 balance. So now the balance is only $4,584.88. Okay, so how much interest do we owe? Well, let's multiply by 0.1. And we get that we have to pay $458.49 of interest. And so the rest can go to capital, so we can subtract that number from $5,053.57, which is our payment for that time, for that year. And so therefore it's $4,584.88. And so there we go. Keep in mind that sometimes these numbers are like slightly different, right? Like off by a couple of cents just from rounding, but keep in mind it shouldn't be off by that much. It should only be a tiny little bit off just by a couple cents ideally. So there we go. So therefore, we ended up paying off the full balance, that full capital, and we ended up paying less and less in interest each time. In fact, significantly, because our payment went up each time and our interest is going down, meaning any additional money we're putting towards our payment at that point is just able to go to our principal. So that's kind of the nice thing about that too. Along with more of our even the original payments we were making, more of that can go to the principal as well. All right, well, any questions, feel free to write me a comment, and we'll see you for the next one.